Hello everybody, this is our third tutorial on SAP 2000 version 14. In this video we will see how to model, analyze and design a 3D frame elements. And here in this video we have this building. This building have got columns and beams, and we have a solid slab on the roof. You have these kind of walls around the building, and there is a parapet wall on the top type beam of this element. And so this element has got also foundations, isolated footings, so isolated columns will be provided in below the grid beams. So we will see how to model each and every element here, and however the walls will be modeled as a dead load on the beams. So we will see how to calculate these wall loads on the beams and as well as on the top type beam. So let's go to the floor plan. Let's see the floor plan. Here, this is our floor plan. We have 3 rooms, one room here, this one, the center to center distance is from A to B 2 meters, and then 6, and horizontally in the X direction, this in the Y direction 2, 6, in the X direction between axis 1 and axis 2 there is 5, axis 2 and 3, and axis 3 to 4 there is 5 meters. So this will be what we are going to model. We have a frame, a beam that is tying up all the columns together. Here a point to be noticed: a column has a long direction, long dimension here, and a short dimension here. So we will see how to model this also on this tutorial. So let's start. So let's open our software. So this is SAP 2000, my shortcut. It will take a few seconds, then it will open up. Okay, so we'll say next. Then this is the tip of the day. You can read it or you can just close it. Now, as we said, always our first step is to correct the dimensions here. So let's correct it into kilonewton, meter, and degrees Celsius. So let's click on the black screen here. Now it will be inactive. Now let's see the givens. First of all, this is the given. You are given the unit weight of the HCB wall as 18 kilonewton per meter cubed, and the thickness to be 0.2 meters, and the roof slab thickness 15 centimeters. Live load on the roof slab 0.5 kilonewton per meter square, and footing depth around 2 meters. And for this example we will use a load combination of 1.3 dead load and 1.6 live load. So we will design only for these gravity loads, no earthquake, no wind load, and so on. Okay, so this is our given, and now let's go. Okay, so let's start with a new model. Now, so far in the previous videos we have seen how to use the beam element here and a 2D element here and so on. Now today let's use maybe grid only. You can use that. Let's say simply okay, we will edit it later. So now here, let me edit here. So if you want to edit the grid or the grid data, just right click on any place on these windows, then say edit grid data. Now it says global in the system, so here modify show system. Now we will insert our data here. Okay, here and here. So now in the X grid data, here you have A, B, C, D, but on our example in the X you have 1, 2, 3, 4. So we have to change that. So here we have 1, 2, 3, 4. Now if we are using ordinates, we will write the ordinate of each axis. So axis 1 is at 0, axis 2 is at axis 2 is at 5 meters from 1, so it will be 5. Then axis 3 is at 5 plus 3, it will be 8. So here will be 8. And axis 4 is, let's measure from axis 1 again, 5 plus 3, 8. 8 plus 5 is 13. So here we will insert 30. Now it's done. You see here. Now the Y grid data, it is A, B, C, not 1, 2, 3. We will say A, B, C. The last one we don't need it, so we will delete it. Just select, highlight it, and then click delete. Now A is on ordinate 0, B is on ordinate, we will measure it from A, so it is at 2 meters. So we will write here 2, and last one is at 2 plus 6, it's 8. It is 8 here. So done. So this is our floor plan, how it looks like. Finally, we will have the Z grid data. Here you have, in our example, in this example we have the foundation, so the footing level must be mentioned here, and the grade beam location must be mentioned here, and the top tie beam must be mentioned here. So we need 3 Z grid data elements, so these 3 will be enough, so we don't need the remaining 2 data, so we'll delete it. So Z1, you can say uh, footing, okay, footing. So the footing will be, it says in the given, it is at 2 meter depth below the floor, below the grade beam. So here you will say minus of 2, because I am using my reference on the grade beam. Then it says here the grade beam level, so grade beam level, we can call it any name that we want, so it is at 0. Then the top tie beam level, it is at 3.6 meter. Okay, it's already given there. So now we can say okay here, then okay here. Now this is how it looks like. Okay, the 3D is here, the 2D is here. Now after defining the grid data, we will define the materials. Okay, now here we have 2 types of materials. The one is concrete, the other is the reinforcement bar here. So here we will define 2 materials says here. So here you have 2 default materials. The first one is for concrete, the second one is for the steel structure. But now we want our own, so this one is concrete. Let's add a copy of a material. If you want, you can edit this one. You can say modify, it says here concrete, you can edit this one. If you want, you can have a copy of this, add a copy of the material, and you can call it whatever you want. Okay, let's call it C25 concrete. The material is concrete here, already selected. Here weight per unit volume according to the Ethiopian code as well as the Euro code, it's around 25, so let's call it 25. Here if you have the actual modulus of elasticity value, you have to insert it here. The Poisson's ratio, you have to insert it here, and coefficients of thermal expansion, you have to insert it here. Almost these are enough for me. If you calculate it by the empirical formulas, you will get around maybe 24 something, 25, around there. So just we'll leave it like this. The shear modulus, it will be calculated automatically by the software. so you cannot edit it here. Okay, now here the other properties for concrete material is the compressive strength F prime C. This is the cylindrical compressive strength using a standard cylinder. This is around for C25. This is 25 megapascal. 25 times 0.8, you get around 20,000. Okay, 20,000. Then we will say here okay. So now C25 is already defined. We don't need this material, so we can delete it. Okay, now this is a steel structure, but we want only reinforcement bars, so we have to define another material here. So here let me say add new material. It says here already steel. Let's call it S400 steel. No, we want rebars here. Okay, take care of here, don't use steel, use rebars, because here steel is the structural steel members. Now we will use rebars here. So here weight per unit volume according to the Ethiopian code is around 77, almost here also 77. You can leave it like this, or you can say 77 kilonewton per meter cubed. Now this is around 200 gigapascal. It is 199.9 something. We can leave it like that. This also like that. Already the default can be left like that. Here minimum yield stress, it is the yield strength of the element, the reinforcement bar. Here for S400 we have what? 400,000 divided by 1.15. This is 347.826 megapascal, or if it's in kilopascal, it's like this. Now this one is the FU, the ultimate, so it's like this. Now this element and this element are used by the software. It is 1.1 times this, and this one is 1.1 times this. So here 1.1 times 400,000 divided by 1.15, so it will be something like this. And again here 1.1 times, so these are the data that we will insert here. Now we will say okay. Now the material color can be left like this by the default. Okay, so we have two materials. If you want to define the stirrups with a different strength of the steel reinforcement, we can say add a copy of the material, then say let's call it maybe S300, whatever it is. Then here we will change it here. Okay, we'll change it here. It is 300,000 divided by 1.15, like this. It is 300,000 this. Now this one is, this time is 1.1. It is 1.1 times 260,869.56. Like that. This one will be 1.1 times this. 1.1 times 300,000. So it's like this. So for the stirrups, we will use S300. Done. So we can delete this one. Delete material. So only we will have these three materials. Okay. The next step is to define the sections. Okay, the sections. So here define section property, frames and slabs. Okay, we will need these two materials. So first we will define the frame section. That's called add new property. If you have a property that can be imported, you will select here, but now I will select from the available materials. So add new property. Here it says frame section property type. Here it says steel. We have to select concrete. Then we will select rectangular, because our columns as well as the beams are rectangulars. So now I will define the columns rectangular. So here let's call it column. Okay, here the columns are given to be 200 by 300. Okay, 200 by 300. So here the depth will be 300. Here let's call it 30 centimeter by 20. Okay, let's give it a name. This is just a name, it doesn't affect your calculations. Here it will be where it will affect. So here 0.3 meters, because the unit of measurement here is already in meter. You can see it here, and the width is 0.2, like this. Now you have this kind of a column section. So let's go here, concrete reinforcement. Here it says longitudinal bar S400, it's fine. Confinement bar, that's the stirrups, let's select S300. Then the design type, it is column, this one. Reinforcement configuration, rectangular, fine. Then it says longitudinal bar rectangular configuration. Here we will insert the clear cover for the reinforcement bar, the clear cover. Okay, so around 25 millimeters, so it is around 0.025 meters. Okay, it says here number of longitudinal bar along 3-direction face and along 2-direction face. What's this 3-direction face and the 2-direction face? Let's see it here. Now if you have a column section here, you have axis 1 longitudinally and axis 2 here in the longer direction and axis 3 here in the shorter direction. So the reinforcement bars that you see here along axis 2, we have 1, 2, 3 layers. Along axis 3 we have 1, 2, 3 layers. For example, if we don't have this one and this one, along axis 2 we have 1, 2 layers. So you will insert here along axis 2 2, and along axis 3 1, 2, 3 layers. So you will insert 3. But for our example, let me use 2 by 2. Okay, 2 by 2. So I will insert here 2 by 2. Now longitudinal bar size, then I will select from here. Let me use the diameter 16 or 14, whatever it is. Let me use 14 here. If you want the detail of this element, you can select here and you can say what is D16, 16D here. Then it is area will be like this, bar diameter it is 0.016 meters. So it's okay here. Now here it says the confinement bars size, let's use 8D here, 8D, and here longitudinal spacing of the confinement 15 centimeters, whatever it is, fine. Number of bars in number of confinement bars in 3 directions as well as in 2 directions, let's use 2 by 2. Okay, this is the stirrups along axis 2 and along axis 3, so let's have only 2 by 2. Now here the reinforcement to be designed, then okay. Now you see 2 2 is okay. So now you can select the color that you want, whatever it is. Let me select this color, and here we say okay. This is the column defined. Now let's define another material, that's the beam. So it is concrete here, rectangular here. Let's call it grade beam 30, or let's say 35 by 20. So here you have 0.35 by 0.2. Here it shows us a column section, so we will change it here into beam. Now he says concrete cover to the longitudinal rebar here. Now in the previous one it was the clear cover, now it is the concrete cover to the longitudinal rebar center. So we will say the concrete cover plus the diameter of the stirrup plus half of the main bar. Now our main bar, let's take around 520. Let's use a clear concrete cover of 25, strap of 5.8, and the main bar of 520. So if we sum them up, we get around 25 plus 8, it is 33. 33 plus 10, it is 0.43. So 0.043. The same here, 0.043. Then we will say okay. Now here we have to define here the material for the confinement as 300. Don't forget to select this beam element here. Say okay. Now you have a beam element here. Okay, here don't forget to check the material here as C25 for the concrete. Okay, because it's a concrete section. So let's say okay. Again, let's define the top type beam. Let's select a copy of the property TTB 35 by 20. So the same thing here. So let's select OK. So we have these three frame elements. Now let's say OK. The last one is let's define the slab. So define here section property, here area sections. Now it says here shell, plane, solid. So here we will select shell, add new section. Here you have around 6 selection options. Now let's first define the name. Let's call it slab. You will get the difference of this shell, shell thick, shell thin, plate, all this, the difference between these elements. In my video, the link will be shown below, so you can view that one. So now for this video, I will select shell thin. Now here it says the material, so let me select the material C25 because concrete. Material angle we will leave it 0. Membrane it says 0.15, 0.15. Now let's say okay, then okay. Now let's model it. Okay, let me first model the columns. So here you have the modeling options. So you can select the quick draw frame element here. Now let me select the column already selected. Now let me go to the vertical view, XZ view. So here when you have the 2D view here, you have the 3D view here, and it's highlighted here. Okay, so it is showing you this front view. So let me simply highlight it like this, like this. Now here let me see the 3D view, and let me show you the extruded view. Let's select here view by color sections, and here extrude view. Okay, if you observe here, the column orientation is in perpendicular direction of the original columns. The columns are like this, but on top you have the arrangement in this direction. So we have to rotate this element into the appropriate direction. So I will select all. Let me select this one. Then here it says select all. I have selected all. Then I will rotate it by 90 degrees. So assign frame local axis here, then by 90 degrees. Okay, now you can see that it is perfect as we wanted it. So done. Now this is our columns. Let me select them all again. Go to here, select them all. Let me copy it. Okay, I will replicate this on 2 times. Okay, so the first one I will replicate it at 2 meters from the current location. So I will go to edit, replicate, or you can simply Control R, select Control R. Then it says linear. Yeah, it is around linearly. So we will select here it is along the y direction. As you can see here, it is along the y direction. So I will go to the y direction. It asks me the distance to be moved. It is 2 meters. The number of copies 1 only. So I will select OK. Now it has copied it. Again, let me select the previous selection. Get previous selection, PS here. Now the previous selection is already selected. Now I will again Control R. Now it will move how much distance? This element will move from here up to here, a copy of this. So 2 plus 6 is 8. So here 8. Then I will say OK. Now it has replicated it here. So the columns are done. Now let me go to the floor plan, that is XY. Here you see that it's highlighted at the bottom around the foundation. So let me go up here, or you can see it here, Z equals -2. So let me go up one step. So I will get the grid beam. Now I will model the grid beam here. Let me select the quick, then let me select the grid beam here, grid beam 35 by 20. I can at one, I can already model it by one click. Now let me go up. You see here I am now in the top right beam. Let me select the top right beam here, and again let me select it like this. So now you can see here that I have already modeled the whole frame. Okay, the whole frame is now modeled. If you want to change the colors of maybe the column and the beam looks the same color, so I will go to here, frame sections, the columns, modify the color here. Let me change the color here, maybe yellow. So I will say okay. So now it looks a more beautiful one. Okay, can change it anytime you want. So now let me assign the slab here. So the slab here, it is now we are already at the top level. So we can say, let me select the quick draw area element here. Now it says slab. Okay, so if you have a different elements already defined, you can select the element that you want. So now select here, 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 here. Done. Now you can see the view. Now our slab is already defined here. The next step is to assign the support condition for the foundation. So let me go down. Now I am on the foundation level. It says here Z equals -2. So let me select the whole element here. So now you'll see that the joints of the support is already selected. I will say assign joint restraints, then I will say fix it. Okay, now already our model is complete, only the loads are remaining. Now after we have modeled the whole model, let me define the load patterns. Load pattern. Now the dead load is already defined by default. Now let me define the live load. The live load, let me call it live. Let me say add new load pattern, and let me say okay. Then let me define the load combination here. Load combination, add new combination, then combination 1, whatever it is. Then the dead load is set 1.3 dead load, add, and 1.6 live load, add. Then let me say okay. Now we have the load combination, and in the given we are asked to design for this load combination. So okay, now here let me select the beams on which we have the wall load. If you can see it here, this is the walls. The walls are already on the beams around here, not on the front one and on the veranda. So we don't have any walls here. So now I will select only the beams that have the wall load. and the partitions. Then now let me calculate the weight of the wall. So the thickness is already given, 0.2 meter. Height is 3.23. This is the total height is 3.6 minus the depth of the top tie beam 0.35 to have 3.26 meters. So here you have this one. The unit weight is already given 18, so this times this times this will give me 11.7 kilonewton per meter. So now assign frame loads distributed date, yeah, uniform distributed load of 11.7 kilonewton per meter. So now say okay. Now the wall load is already assigned to the grid beam. Now let's go up to the top tie beam. Now this is our top tie beam. So let me select the top tie beam. This one, this one, this one, and this one, this one, this. Because we have the parapet wall only around the periphery, we don't have it here. Okay, since we don't have it here, we'll only select the periphery top tie beams, and we will say assign frame load distributed how much we didn't calculate. So the height of the parapet wall is 1 meter, so 0.2 times 1 times 18, around 3.6. So it's around 3.6 date. Okay, now on the ground floor slab, the slab rests on the ground, so we will not have the load transferred from this slab to the beam, so we will not define it here. Now we have to define the live load on the roof. So let me select the roof slab here, and let me assign area load uniform shell, then live load here. It is around 0.5 as we are given. So we are say okay. Or you see here this x, y direction, z direction, it is in the downward, so minus of 0.5 kilonewton per meter square. This is the area load. Now the load is all defined, the frame is already defined, so now we are ready to run the analysis, even though it will ask us to save it, but let us analyze it. Now we don't want the model, so let's select do not run, only run for date and live. Now let's say run now. It will ask us to save the file, then only it can run it. Let's see here. So let's call this one tutorial 3. This is the deformed shape of the element. It is so much exaggerated. Okay, do not think that our building will fail like this. Okay, so this is our 3D building. Now if you want to design, we will go here, start concrete design. I will select here. Now I will select the code that I want. Click here. Now design code, let me select the Euro code. Okay, this is our default parameters. I will select OK. Now I will select the load combination, select design combos. I will select this one. I will say add. Now this one I don't want any automatically generated code based load combinations, so I will say I will unselect this one and I say OK. Now I can say design. Here it will design the frames. Okay, it will design the frames, it will not design the slabs. This is my frames already designed. Let me select the millimeter, kilonewton and millimeter here. Now let me see the floor plan XY here. Oh, this is the foundation. This is the top beam. It says 122 millimeter area of steel is required here around the support. Again here around the support, here like this. Okay, this is the design of the top beam. And if I go down, this is the design of the grade beam. This is the area of the reinforcement in millimeters, 253 millimeter. The negative reinforcement here and negative reinforcement here and positive reinforcement here. So this is the final reinforcement, reinforcement provision according to the euro code. So based on this you can prepare your details. Okay, your details. In our next video we will see how to import this into Excel sheets and so on. Okay, so if this video has been useful, please don't forget to subscribe to the channel for more videos, and please support the channel with a like, share, a comment on questions. Okay, so thank you, see you next time, goodbye.